So we could do homework problems, we could do stuff from the practice test, we could do whatever that you guys want to. And if nobody has questions, we can just sit here and look at each other. We could leave early, if everybody's ready for the test. Is that true? No? Okay. Say again? First question? Okay. Yeah. Did anyone give or have an answer for number one? What is variation of parameters? That's when we do what? Variation of parameters is when we do what? I'll get it started. We figure out YC. And then we do something based on that. And you're like, can you give me a little more, Jeff? So, in general, I'm not as concerned about the name of process as opposed to you being able to carry the process out. But there's a practice test, you can look it up. So let me get you started. So if I solve YC and I get this, variation of parameters is something about the particular solution, the YP. What's the assumption I make for variation of parameters?
It's U1, Y1.
Yeah. Where U and one and Y1 are U1 and Y and U2. Good lord. U1 and U2 are functions of X. And of course, that's exactly the same thing as reduction of order. It's the same kind of idea, except it goes one step back. Reduction of order says, if I know one particular solution or one C, I could assume they're linearly independent. So this is basically that. Not assume, but they must be. So if I say the YP is some function times Y1 plus some function times Y2, I'm guaranteed that that's true. I know that's true. And on the surface, it might feel like, I don't know if you guys thought about this too much, but to me, when I first learned this, I'm like, well, that could be making everything horrendous. But it's the only thing we can do in certain situations, so, oh well, too bad. The very first example I did with you guys, the U and Y1 and the U2, Y2 ended up being like terms, and we put them together. You guys kind of with me? So, because if the YP is supposed to be 4x, and you got U1, Y1, and U2, that means whatever the hell they are, they're going to combine to make whatever the answer is supposed to be. Are you guys all with me? Okay. So what's the idea behind it? Linear independence. Not only do my Y1 and Y2 have to be independent from each other, but the YP has to be independent from those. So if that's true, then it makes sense that this must be true. And thankfully, assuming that, doing all the craziness with it, we actually end up with something I can directly analyze, right? I can solve after making this assumption. Do you guys remember, so does everybody cool with that? That's basically what I want for number one. And I'm going to ask you at least one, if not two, conceptual questions, everybody's favorite. Does anyone remember, and hopefully you do because you need to, what U1 prime is in terms of all this stuff? So here I would, what's the Wronskian going to be for this problem? Y1, Y2? Y1 prime, Y2 prime, which is what it always is. That's what the Wronskian's defined to be. So now that I got W defined, what would U1 prime be? Negative?
Y2.
Y2.
F of X over Wronskian.
Now real quick, the F of X is the part where people make the most mistakes. For example, on this problem, I would have to use variation of parameters. Is 4x, is that F of X? Why not? Because I need to make the first thing 1, correct? So my F of X will actually be 4 over X, right? Become a 4. Let me stop for a minute. That is the most common place to make a mistake, is to not identify the F of X correctly. And if the F of X is wrong, everything's wrong. Because U1 is based off of f of x. And what's u2 prime? Over the runs, yeah. Become a W. You guys kind of with me? You will get exceptionally weird ass shit if you don't identify the correct f. Well, sometimes you will. The correct f, right? And of course, if you show me all your work, I give partial credit. If that's the only mistake you made and everything else was correct, I grade harder on the concept. So if you make a little brain fart or whatever, that's not a conceptual mistake, right? That's sort of a misconceptual, but it's an understandable one. We see the function, we're like, that's f. No, you got to make sure. So a problem like this is that f of x. And real quick, why am I even identifying f of x? Why am I saying this would be a variation of parameters? Secant. And secant is funky ass. With its derivatives, secant is not directly related to just itself. Secant tangent and the next derivative is crazy. Are you guys?
Yeah.
And the whole idea of undetermined coefficients is the function that's there is directly related to its own derivatives. Secant very quickly departs from itself. Okay, so I gotta use variation parameters. What's the one thing I gotta be careful about when I'm trying to figure out f? First number's not a 1 yet, right? So divide by 3 and then I know what f is. Are you guys someone with me? All right. Yes. Oh, the reduction of order. There is a shortcut you can memorize, and you can use it. And I think I was honest with you guys. I didn't memorize it. I just always do the full-blown reduction of order, right? You guys with me? Did I put a reduction of order problem on here? No. Damn you, Jeff. Real quick, if I wanted to create a reduction of order problem, this is something students don't get to do too often. If you wanted to create a problem that you could relatively easily tell what the answers are going to be, so I want to do a reduction of order problem. What's reduction of order problem mean? What do I have to go in knowing? I'm given some DE, right? Let me make something up. You can do it, Jeff. There it is, buddy. So reduction of order means what?
You have like one of the y1s.
I know like what y1 is.
Yeah.
And then I make the assumption that y2 would be
Multiple of a function.
uy1, some multiple, something makes it linearly independent, correct?
Yeah.
Okay. Are you guys with me? There's a shortcut to what that process leads to that I don't have memorized. So who hasn't memorized? It's e to the
Negative integral p of
negative
x
integral p of x dx
over y1 squared.
Over y1 squared. Right. I am not the biggest fan of memorization, but I left that up to you guys. You can memorize it. I will put a reduction of order problem on the text. Right. So let's do this. If I tell you that one solution to this, let me think ahead a little bit. You can do it, Jeff. You just made the problem. There it is. Is e to the 5x. How would you start doing full-blown reduction of order?
Multiply by u.
Yeah.
U e to the 5x.
I like it. So I mean, this is not that involved. Variation of parameters. I had a lot of motivation to memorize the end result because my God, if you do the full-blown variation of parameters, that'll drive you more insane than you currently are. If you're not insane already, you've done well. So this would be that, right? Is that cool? All right. We hope as a math teacher I could make numbers, but oh. And then y double prime would just be u double prime e to the 5x plus 5u prime plus 5u prime, so plus 10u prime plus 25u. Is that all right?
Yep.
Let's do this. So I'm gonna kind of, with your help, I'm gonna do this problem. Then we'll check it against the shortcut, right? So now I throw all this stuff in. And you guys, at this point, you must be used to this, but there's a lot of places where you can make mistakes here. That says y double prime, so all this mess gets involved. That says minus 3 times y prime, so you gotta multiply this by negative 3. So I understand there are multiple places where you can make one little mistake. But I want to remind you, as we do this, so let's see. This is why the more work you show me, the more partial credit I can give you. So that's y double prime minus 3 times y prime minus 10 times y equals 0. All right, let's zoom out a bit, Jeff. Oh, as I was doing the answer key, I almost turned the paper this way just to help me fit everything in, but I decided not to. So there could be some homework where you actually turn your paper this way. Trust me, in a lot of my math classes, that's exactly what I did for a lot of my homework. You just turn the paper this way so you got more room to fit the whole damn thing. You don't have to if you don't want to, just make it clear what the hell's going on. Now when I start putting like terms together, what tells me I'm on the right track? This is how you pick up on a simple mistake. Which parts should die?
The U's.
The U's. Because the whole idea of reduction of order is to rewrite the original DE so that you get a double prime and a prime, because then you can knock it down by a prime, right? That's where the reduction of order name comes from. So all of my U shoulds, you can't, and if it doesn't, you more than likely just made a constant mistake, right? You forgot to multiply by something or whatever, right? So here, thankfully, 25 minus 15 minus 10 dies. Yay! And then I get 10 U, blah, 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 blah. Okay, exactly right. Now here the e to the 5x's cancel. I made this homogeneous, so I was being real. The e to the 5x's cancel, right? And then I make this assumption about let w equal u prime. Yes, is everybody with me? Okay, okay. So then I'll end up with like, if I do w prime equals 7w negative, I can do dw over w equals negative 7 dx. I'm just going to do this kind of quickly. Natural log of w equals e to the negative 7. Get out of here, Jeff. Yes, that'll eventually be that, Jeff, but not yet. There you go, buddy. So then w equals e to the negative 7x. Is that all right so far? Therefore, u prime equals e to the negative 7x. So u equals, is that cool? And then, therefore, y2 equals u e to the 5x. So y2 equals negative 1/7 e to the negative 2x. Now what's funny is, whatever number is there doesn't matter where shit. I just replace it with C2. It just get kind of absorbed into that. Is that cool?
Yeah.
Okay. Now, what's the short? Oh, so let me just write this. So then y would be C1 e to the 5x plus C2 e to the negative 2x, and of course, this whole thing is absolutely silly because if I just make the ox, I'll get m minus 5m plus 2, and that's where the negative 2x comes from. Okay. So again, sometimes I like to give you a problem where you have to do this crazy ass long thing, but it's a simple problem you could do a different way to make sure your answer is correct. Yes? So you're welcome for when I do that. What's the shortcut? So let me write this again. And I know this y1 is e to the 5. So the shortcut you just told me was y2 would equal y, isn't that y1 times?
Times the integral, and then it's e to the negative, or it would be just 3 dx.
Yeah, p, right?
Yeah.
So negative 3, so I got you.
And then over y1 squared. So
And I can't remember,
e to
is
the
that
10x.
inside the integral?
Yeah, it's inside.
Inside the integral, okay. Over e to the 5x squared, right?
Yep.
So e to the 10x.
Yep.
dx, I love all that shit. Okay, so the y2, I don't know why I didn't put y1 there, so that's e to the 5x. Integral, this would be e to the 3x over e to the 10x is e to the negative 7x.
Mhm.
And you start to see similar things here, right? Of course, this is a shortcut to what I just did. So you're going to so this will be y2 equals e to the 5x times negative 1/7 e to the negative 7x. And of course, that's where you get your e to the negative 2x, blah, blah, blah. Is that all right? It was a little fast, but where I did it all the way. To be honest, what I did wasn't that much longer than that, actually. But, you know, it's up to you. So you can remember the shortcut. I might ask you to do the full-blown part, so we'll see. See how I'm feeling when I finish this up. Okay. I like it. By the way, while I'm thinking about it, anybody need a copy of this, the practice test? Okay. All right. So again, today is wide open. I do want to do number 5 because I didn't finish it up on the key. But does anyone else have any specific question? Yeah.
When you're working with a homogeneous linear differential equation with constant coefficients, and you have that situation where you have to do the quadratic formula, then you have the Euler's stuff, and you have to find alpha and beta. Can alpha be 0?
Totally. Yes.
Okay.
I love it. So, all right. Let's see. So, what's the situation? That's case 3, right?
Mm-hmm.
So, what is the solution? So, I get my two solutions: alpha plus or minus beta I. Yes. So, what does my solution look like then in that case? E to the alpha x. Yeah, C1 cosine beta x. Sine of beta x, okay. So if alpha is 0, so for example, if your homogeneous, if your auxiliary equation is this, you could do it, Jeff. There you go, buddy. Then you get m equals plus or minus 3i. So beta is 3, but alpha is 0. Well, what's e to the 0?
1.
Yeah, cool. And by the way, we already know, real quick, we already know the solution to this stupid thing. We already know the solution to this. What do I take a second derivative of that would be related to itself? Cosine or sine. And where would the 9 come from if the inside was 3x? So it's funny, it's that form has to recapture shit we already did because we know how derivatives work. We did several examples of functions where we knew the answer just by observation. That better match with the freaky ass things we do, right? Like this is pretty freaky. If alpha 0, it just goes, oh yeah, I already knew that. I already knew it was going to be a combination of cosine and sine, where the inside's 3, because that's where the 9 would come from after a couple of derivatives. Is that cool? So it's kind of nice to see a more complex thing reducing down to something we already knew. Okay. So, for example, I think that same thing is on the practice test. Which one was it? This guy. Well, it's not exactly this guy, but which one? Not that guy. Which one? There's another one here. This guy. So, what's the ox? I'm really hoping everybody's cool with that abbreviation. Those abbreviations. What's the ox?
Z1 cosine.
Hmm? Yeah, m squared plus 16, right? Equals 0. But if I just look at the isn't that y double prime plus 16y equals 0? Don't we already know the solutions are c1 cosine 4x plus c2 sine 4x? We already know that by observation. If you forget that, you can do the full-blown stuff. You'll get alpha 0, right? It'll still work out, and then you go, oh yeah, shit. So if you realize that on the test, you don't have to do. You can just say, I know that YC is c1 cosine 4x plus c2 sine 4x. So you guys with me? Little tears would come out, right? So I used to I still do. I say, the more you know, the less you have to do. Yeah, okay. With that said, you've got to show me something, but yeah. So if you can go straight to YC equals and just put down what that is and then keep going. Now this specific problem, let's go ahead and do this one since I sort of started doing it. That's the one I didn't finish on the practice, on the answer key, number 5. So let me write it down. This one's going to be sort of a bear. You guys probably see why. So this leads to YC equals C1 sine 4x plus C2 cosine 4x. So why does that screw me over with the next thing I'm going to want to do? What's the next thing I'm going to want to do with this?
Assume the form.
Yeah, I can assume the form of the answer because this function here is nice and this is a constant coefficients, right?
Yeah.
So I'm going to assume yp is what? I would like to assume that it is a sine 4x plus b cosine 4x. But of course, why is that bad?
That's the same as that.
Because I think everybody's got this. That is what would come from this, correct? That assumption we would make, what would create this after a few derivatives would be some combination of sine and cosine 4x. But I already know that any combination of sine 4x and cosine 4x makes this 0. There's no way in hell it's going to make it this. So that's where I have to do what here, of course? Throw in an x. I love it. Can we stop for a minute? Okay. So, I think you guys see now how this is going to suck a bit. And at most, I would give you like one problem that's going to have this massive, not
Derivative.
massive, but after a couple derivatives, do you understand? We're going to
Yeah.
get a decent amount of stuff. I try desperately not to give you too many problems where it's just basically busy work. Where not only do you have to do the derivatives, you have to keep track of all the parts. Are you guys with me? You should be able to do that, but you're going to have an hour and 20 minutes. So I'm not going to do that to you a lot, right? If I do, you can kick me in the shin. So now I just start, now that I made this assumption, I just start doing what this needs me to do. I don't need prime, but I need double prime, so I got to build. So here, you guys, I'll catch up to you. Go ahead and figure out yp prime and yp double prime. This is a problem where you start to understand why you might want to turn your paper out for sometimes. Came at a really weird moment. We're all very quiet. We're doing number 5 on the practice test. Yeah. All right. So one thing that's nice to do instead of turning your paper around is just sort of use the natural symmetry in the problem itself. So I'm gonna have a first derivative, not too bad. I got two product rules, not too bad. If you see a mistake I made, please let me know. I'm just a human, so I'm okay. The next one, I've got this piece and I've got this piece, and they are sort of symmetric. So it's not a bad idea. I kind of line them up. So I've got 4a cosine 4x, and then this one, if I take the derivative, I get another 4a cosine 4x, and then I got the product rule piece for that one. Is that cool?
Yeah.
So negative 16ax sine 4x. And then I'm going to have very similar stuff here, and it's kind of a way to, as you do this, you can kind of check to yourself. You should be getting very similar stuff. Does that make any sense?
Yeah.
So instead of turning your paper around, you can kind of like collect it, so you can kind of visually observe that you're doing the right way. So of course I can kind of clean this up a little bit. And then I can clean it up even a little bit. Well, let's see. Let's throw this stuff in first, yeah. It's a good idea. Okay, I think that looks okay. You guys are okay with me? Okay. Bookkeeping becomes huge in higher level mathematics, for sure. Now I'm going to throw it into the equation. So I get 8a cosine 4x. I'm going to put my cosine stuff together. Which is what I should have done from the beginning, but too bad for Jeff, we didn't. And then I have to do plus 16 this. Right, so plus 16 this. So it'll be plus 16 ax sine 4x plus 16 bx cosine 4x. Let me show you that.
It will usually do that, right?
Say again?
It will usually do that.
Well, here's the thing. Let me see if you guys, you knew this was going to happen. You knew these have to die from the very beginning because I don't have an x here. Do you see that?
Yeah.
Or they could have b is 0 or a is 0, but it kind of makes sense that these do die. But if a is 0 and b is 0, then all of this is 0, so that can't happen. Okay. Will it always happen? It depends on what's here, right? Okay. So then, these die. And this equals 8 sine 4x. So then what's a? 0, because there's no cosine 4x's. And what's b? Negative 1. Kick ass. So then I know yp is 0 blah, blah, minus x cosine 4x. How's that look? Is that alright? You guys are. So therefore I know that y equals c1 sine 4x plus c2 cosine 4x minus x cosine 4x. There's my yc, there's my yp. Could I have done this with variation of parameters? Yes, of course I could have. Would you ever? Holy shit, no. Unless you have a crazy ass teacher that says you should do it. I try not to do that. We'll see. Okay. Now, I promised somebody I was going to tell you. Any questions on that problem? That problem, oh, are we done? I think this was IVP. All right, so we're not quite done yet. I almost forgot about this piece. So now let me write down where we left off. Is this your favorite part about higher level mathematics? Is like, I've done so much and I'm not done yet. Anybody yet? No? Yes. So now I know that y of pi over 8 equals 3. So put a 3 in there. I'm sorry, if I put a pi over 8 in there. Real quick, what is sine of 4 times pi over 8? Sine of pi over 2?
1.
1. And what's cosine of pi over 2?
0.
0. And then I've got, oh, this is going to be real. Oh, yeah, what's cosine of pi over 2?
0.
0, yeah, so C1 is 3. Oh, that kicks ass. Sorry. I didn't finish this problem, so as I'm doing it, I'm learning with you what the answer is. Okay, see you later, man. Oh, here.
Thank you.
Sure. So I know C1 is 3, which means I could immediately rewrite this before I do this. It doesn't really matter. So I got y equals 3 sine 4x plus C2 cosine 4x minus x cosine 4x. So then I want y prime, Jeff, giving yourself no room, buddy. That would be 12 cosine 4x minus 4c2 sine 4x. Oh boy. Minus cosine 4x plus 4x sine 4x. Oh god. Double check me on that. Okay. Just taking the derivative of this. You guys all with me? This is so terribly exciting, so I appreciate everybody remaining calm. And you can put those together, but who cares? Because I'm going to plug a pi over 8 in, so all the cosine, when I plug a pi over 8 in, all the cosine stuff we already know is going to cancel, because this will be 4 times pi over 8, pi over 2, cosine of pi over 2 is 0, right? Sine of pi over 2 is 1, and this, of course, is pi over 8. That's what I'm throwing in there, right? And that's supposed to equal 0. So can somebody just tell me what C2 is?
Pi over 8.
It's gotta be pi over 8, yeah. Oh my god. So therefore, the solution is, I know what C1 is now, and I know what C2 is now, so the solution is gonna be 3 sine 4x plus pi over 8 cosine 4x minus x cosine 4x, Jeff. Chumbawamba. Alright. I'm really hoping I did all the steps correctly. So, let me, oh, go ahead.
Could you go back to where you got A is equal to 0?
Which one, sorry?
A is equal to 0.
A is equal to 0. Oh, that's way back here. Here. So if I equate coefficients, there are no cosine 4x's, therefore this must be 0. Yeah, okay. Yusuf, was it you that I was talking about Wolfram Alpha?
Yeah.
Yeah, okay. So I want to show you, let me just say this phrase again. Wolfram Alpha. Does anyone know Wolfram Alpha?
Yes.
Okay. Some of you guys might know it a little too much. Maybe you pay for it. Now the funny thing is, what Wolfram Alpha is what it math is 1% of what it does. It's stupid. If you've never played around with Wolfram Alpha, you want to get in there, right? It's not ChatGPT. That's a whole other thing. Wolfram Alpha is built to be like a math engine. It's built to be a knowledge engine. If you ask it something like, how old was Mickey Mantle when Albert Einstein was 17 or whatever, that doesn't really work, but you can ask it insane things. If you ask it what's the answer to life, the universe, and everything, it'll tell you 42. It's awesome. Anyway, so there's a lot of little Easter eggs in it. So let me just pull it up and show you how it's going to help you guys. If you pay for it, if you pay for it, it'll actually show you all the steps. It'll actually tell you what theorems it's using to solve problems. So don't do that and copy from it. But it's an awesome frickin' study tool for damn sure. So if you don't pay for it, I'll show you what you can get from it. Well, look at that. That's neat. That was just in here. Look at that. So it solved it. So if I put in here the one we just did, which was this, I gotta remember how to do the. Well, let's see. What was it? 8 sine 4x. All right, let's just put that in there, and then I'll see if I remember how to put the initial conditions in there. Is that what we got? Yes. If you hit the step-by-step solution, it'll say, you gotta pay for it. But do you see how, look at how much information it gives you as it solves the damn thing. It's kind of silly. When this first came out, a lot of us math teachers were like, holy shit, we're just like English now. Because what happens in English? People get papers from the internet, on the interwebs, and then English teachers have to have things where they have to turn it in, where they feed it somebody's paper and it tells them if it looks like it was plagiarized, right? You guys all with me? And of course, sometimes students don't change names in their thing, and I'm like, well, make it hard for me. But thank God I don't teach English. And then this happened, and we're like, oh shit. But if you do pay for it, it very often solves things in really, really weird ways. It does something what one of my professors called opening a walnut with a sledgehammer. So it'll solve a really basic problem using this super advanced method, because that's the quickest way for it to remember how to solve anything. It's just do the most advanced method because it works for everything. Does that make sense? So a student will just copy that shit down, and I'll say, what happened on step 1? Well, it just seemed like they were, get out of here. You guys kind of, okay. Anyway, that's all I'll say about that. I can't remember how to tell it. Let's see if it's this. This might not be it. What was it? Y pi rate was 3?
3.
This might not be correct, but we'll see. Where's my prime? I forgot there. Is that it? Yes. Pi over 8 equals 0, right? Not prime. Yes, prime. Okay, is that it? It might not interpret it correctly. Let's see. Oh, it did. Is that what we got? I think it kind of accumulated stuff. Yes, that's what we got, yes? I'm pretty sure. Pi over 8 cosine 4x, yes? Yes! Do you see how I just sort of like put the cosine 4x and just factored the cosine 4x out? Do you guys see that?
Yeah.
It is able to interpret English statements pretty well. And what I love about it is it'll tell you what it thinks you said. And then if it's wrong, you can go back and adjust it. Yes? You guys kind of with me? So even if you don't pay for it, it is a kick-ass way to check your work as you're home and you're doing something you have no idea if the answer's right. Well, there you go. You have a way to figure out if the answer's right. You guys with me? Okay. So this is really good. You should know this exists. And by the way, just to show you, this is probably too small for you anyway, but you can tell me if I am there. That's better. If you just type in like, how many roads must a man walk down? The answer, my friend, is blowing away. Yeah. If you ask, how old was Herbert Hoover when the automobile? I'm going to show off my absolute horrible. Herbert? Did I misspell Herbert? Herbert Hoover, when the automobile was invented. 1672 is before. Wait. The automobile was invented on 1670? I guess maybe so. Anyway, sorry. It's, anybody do any chemistry? You can ask it to do, sodium chloride, sure. And it will give you an insane amount of information about sodium chloride, for example. Anyway. And then if you just hit like, sorry, this is it, examples, mathematics, science, society, everything, blah, 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 blah. Okay. It's stupid. It's just stupid. It's amazing. Okay. Okay, sorry. That's a whole side note. Any specific or general other questions? It's wide open. Yeah.
Can you quickly show the very end of that last problem that you were solving where you got the C2 is equal to pi over 8?
Oh, yes. Sorry. So I did y prime after throwing the 3 in there. So I did y prime. When I throw pi over 8 in, these goes to 0, of course, right? So then I end up with 4 times pi over 8 times 1 minus 4 times c2 times 1. Yeah. And then, of course, just by observation, you know that c over 2, c2 must be pi over 8. Yeah. Okay. Kick ass. All right. Yes.
Can you tell us what equations you want us to use to solve, or methods? Or do you just
I would ask you to use, I might say, use variation of parameters when you might not otherwise do it. But for the most part, I'm just going to say solve this. So for example, you have a very simple level. Which one of these is Cauchy-Euler? How many of these are Cauchy-Euler?
2.
1.
2 of them, yeah.
2 of them, I bet.
Right? You're okay. So these you would do e to the, these you do x to the power, right? I'm not going to tell you, but on this one, how many of these do you have to use variation of parameters for?
2.
2 of them. And somebody did point out that there are, and I forgot to look this up, I told you guys there are certain instances when you can assume the form of an answer to a Cauchy-Euler non-homogeneous or homogeneous differential equation, right? In general, you just go ahead and use variation of parameters. So I need to remember, because off the top of my head, I can't remember what the situations are. But it kind of makes sense that you should be able to do it when the function itself is already some kind of x to a power, right? I'm not sure if that's all of them or only some of them. But anyway. So to answer your question, I didn't say on 4C to use variation of parameters because you have to know you're supposed to, for example. Yeah.
What is the idea behind variation of parameters?
Oh yeah, so we talked about this first thing. What's the idea behind reduction of order?
It reduces the order?
I like it. No, yeah, I don't blame you for saying that because it's like, well, the name tells me, Jeff. But what's the idea behind the setup we do for it? If I know one answer is y1, and I know that both answers have to be how related to each other. So therefore, if I know one, I can make the other one some function of x times z, right? Variation of parameters is just that idea to the next level. Not only does it say that one solution for yc or yp has to be independent from the other, but it says the yp solutions have to be linearly independent from the yc solutions, right? So it takes your yc, and this is why it's called variation parameters. We would consider C1 and C2, we can think of them as parameters of the problem. So I just vary them to become functions instead of constants. This would make the yp linearly independent from these two. So what's the idea behind it? Linear independence. I know that my yp's must be linearly independent from my yc's. Okay. And that's the one where you definitely should go ahead and memorize the end result because it's just a stupid amount of work in the middle. And it always comes out to this. Well, be careful though. When I say it always comes out to this, what assumption am I making? What order? DE. Second order. 11. Because all this work is coming from like a 2x2 determinant. So if I had a third order differential equation that I have to use variation of parameters on, my u1 prime would equal a determinant that I'd have to set up, and my u2 prime would be a determinant, u3 prime would equal a determinant. There wouldn't be a nice, concise way to write the result. There is, but not one you want to memorize. I don't know if you guys are with me. So that is for a second degree. And how many problems have we done that are above second order, sorry? Very few. Yeah, very few. The kind that I like to give you is the constant coefficients, where it's something you have to group. So if I give you one of those problems, all of you better get that damn thing right. So when you make your auxiliary equation, you just factor whatever the hell you have to do. You might have to do quadratic, but if it's a third degree polynomial you hope to God that grouping works. If grouping doesn't work, what would you have to use?
Synthetic.
Synthetic, yes. Or you just sit there and stare at it until it comes to you. And I'm not, at this level, whatever the hell way you factor anything, you just factor it. I almost don't care what method you use to factor it. So that's why some of you guys, I wrote in there, how did you do this? Show your work, but I didn't take points off because you got the right answer. Who cares? So factoring at this level is just, it should just be there. Okay. All right. Anything else you want to focus on? Yes?
What did you mean by grouping?
Oh, so if I had to factor, so let's say I get an auxiliary that looks like this. Alright. What do you got, Jeff? I don't know, Jeff. Let's do, sure. Sure. Then I can group, yes. Or I hope I can group. Because what comes out of these two? 1 squared, and I'm left with. And then I can take a -1 out of here. And then I get. And then you can factor that, blah, 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 blah. Yes. Is that all right? Okay. Just be ready that there's going to be at least one that has complex solutions. How are you guys feeling about this test in general? It's very, so I was asked this earlier, how many of you guys are taking linear at the same semester? A few of you guys. Linear is much more amorphous. Linear is a lot of proving, it's a lot of working with, theorems. There's like 57 theorems or something, it's fantastic. There's a running list of what it means for something, if something's invertible, it's insane, yes. This class, I'm not saying it's easy, but it's much more regimented. It's much more, it's this, you do this, it's this, you do this. It's much more straightforward. So that's why I said, part of my brain loves this class, and the other part of my brain loves linear, right? Okay, all right, enough of that. Anything else? Yes.
I don't understand the algebra.
Oh, which part?
How the 4m squared all of a sudden becomes 4m squared minus 1.
Oh, okay, real quick. All right, ready? You're gonna love this shit. Can you please, you can do it, Jeff. Factor this. What comes out? A b comes out. And then you get what?
4m squared minus 1.
Yeah, okay. Now, what if I replace the b with n minus 5? Don't they both have an n minus 5 now?
Oh, I see now.
Yeah,
Okay, I
yeah.
gotcha.
So then, of course, I get 4m squared minus 1, 1/8, and of course, you could do this. Cover the damn thing you just took out, and you see what you're left with.
Oh, I see.
Let me make my fingers bigger. There we go. There we go. Forced perspective on that. You fool of a took. Yes.
I'm a little confused on the warp.
The which one?
Wronskian?
Oh, the Wronskian?
You
Yes.
have to use it for all the questions, right?
The Wronskian, the most basic thing we use it for is to show that several functions are linearly independent from each other, correct? That was the first time it came up, was just to check to see if certain classes, certain groups of functions create a fundamental solution, set of solutions. They have to be linearly independent. So the Wronskian, if I evaluate it, it'll tell me if they are or aren't. Then it suddenly came up again, not because we forced it to, but because it just sort of naturally came up. I don't know if you guys remember, we assumed something was zero and so forth, and so we set up a system of equations, and the Wronskian just suddenly was there. So it's got two places so far that it's kind of like shown up. I don't know if this is really answering your question though. This is the place where it's used most directly, right? When I'm doing variation of parameters. Are you with me? So you really need to memorize this, and you need to memorize this, and of course the W is the Wronskian. So if you want to, we could do an example of this.
Yes.
Not like for A or C.
What, these two? Yeah, all of these, none of these would need this, right? Because they're all homogeneous. But this one, for example. So it's up to you guys. Now, of course, I've got this on the answer key, but we certainly could do one of these if you want. Or if you got something with homework that was giving you trouble, we can do that. Sorry, what? No, yes, we did. So let's see, 4C. What's the first thing I can do with that? What do I always have to solve for first?
Ox.
Yeah, the ox. The associated homogeneous differential equation that leads to the auxiliary equation. Good lord. So basically just make the zero and then make the appropriate substitution. Now, it's not a bad idea to remind yourself what substitution you're actually making. Because when you get to the m's, your brain could just do the wrong thing. Do you understand what I mean? What is the assumption I'm making for the substitution? Each of the mx, I like it. So whatever my m's are here are going to be these powers of e. I like it. So what auxiliary equation do I end up with? I like it. So then I can divide by 3. Then I have to do what? Bless you. I must bless you. Yeah, I could try to factor it, but this don't factor so nice. This is going to be factored over the complex numbers, which I don't feel like sitting there guessing, right? So what do I do? M equals negative a plus right? That's a square, my boy. 2 divided by 2 is 1, that's insane. Square root of negative 4 is 2i. Divided by 2 is just I. So what does that, what's alpha? Well, alpha and beta in this case are 1. So what does that mean, my YC? Yeah, e to the x times cosine x, yeah, good. Beta x, so cosine x plus c2 sin x. And you can write that, that's fine. Okay. So I got that set. So we that kind of sucks.
Yeah.
So let me write this. Yeah, I'm gonna go ahead and do this. So this would be c1 e to the x cosine x plus c2 e to the x sin x. Yes. All right. Now, looking back at the problem, what method do I have to use to figure out yp? Which is the reason we picked this one.
Variation.
Right. Yeah, I gotta use variation of parameters. So what am I gonna assume is true about yp?
And it's U1 not 1.
Yeah, u1 e to the x cosine x plus u2 e to the x sine x. Let me stop for a minute. Is that okay? Now, variation of parameters. This is the one where we memorized the result. So we went through the beautiful agony of the full-blown thing, and then we realized the end is always going to be the same. So it's going to be based on the same things. Yes? What do I need to figure out? Well, the first thing I really need to figure out, that you guys figured out earlier, let's see, there's a few different ways I want to go. So let's do this. U1 prime equals what?
Negative y to f of x. Property.
Already I know what I need to figure out. I need to figure out what f of x is. I need to figure out what the Wronskian is, correct? What is f of x? You've fallen into my trap. What is f of x?
Cx, cx.
Secant x over 3, yeah.
So it'll be 1/3 e to the x secant x. Let me stop for a minute. Yes? So many of the processes we use needs that first coefficient to be 1. And this is one of them, for sure. So when in doubt, do that. Right? Okay. So if I'm going to do like an integrating factor, don't have to divide by whatever's in front so I can figure out what p is, all that kind of stuff. So almost every damn thing we do, that's part of the process, divide by whatever the hell that is. And you might think, well, it's just a 1/3, Jeff. Don't constants not matter? Well, I'm figuring out yp. For yp, constants are totally important. They're not going to be some generic C1. They're going to be the number, so I need to start with the right number. Is everybody with me? Has everybody got this memorized?
Yeah.
If not, you got until Tuesday. All right. So the next thing I want to figure out then, so I got f of x, check. So now I want to figure out the Wronskian. Wronskian's always the damn same thing. But what functions am I working with? Y1 and Y2, I love it. Oh god, this is gonna be, alright. It's gonna be a little big. So I need a little more. Not that terribly big, but you see what I mean, maybe. So here's my Y1. Here's my Y2. What goes underneath?
E to the x cosine x
Yeah, the derivative.
minus e to the x sine x.
Don't look at the screen, Jeff. There you go, buddy. And down here is gonna be
E to the x sine x plus e to the x cosine x.
still having a pretty damn. The Wronskian is always, for variation parameters, the Wronskian in general is just a line of functions and then the derivatives, and you keep going until you make a square matrix, right? So for us, for these problems, I'm always going to give you a second order. So it's going to be the two solutions we got from YC, and then the derivatives. That's the Wronskian. So now so let's see. I'm gonna get, is this cool if let's see if you guys are cool. Isn't this gonna be e to the
2x.
2x? And this will be cosine x sine x plus cosine squared x. Is that cool?
Yeah.
When I multiply these? Is that alright?
Yeah.
Okay. Oh, minus this here, right? Cosine x sine x. So minus a negative, so plus sine squared x. Oh, I think on my key, let me double check. Yeah, I must have turned these around on the key. It's okay, Jeff. You're fine. So the Wronskian, these kill each other. Is everybody with me? So Wronskian, these die just because they're the same thing. And cosine squared plus sine squared is, yay. Okay. You see how it's really easy for you to not realize that's a basic trig identity. You leave all that shit in there. Can you imagine how horrendous things will look if you leave that shit in there. So, dear God, cosine squared plus sine squared is 1. Yay. Okay. Okay, so let's focus on U1 prime. Here, you guys, please stop. I'm doing too much. I've already done this problem, damn it. You guys figure out what U1 is. We got the Wronskian now. We have identified the correct F. Let me write this down for everybody so we know F of X. And the third E of the X. X. We know that the Wronskian is e to the 2x. Yeah, okay. That's right. Just so you guys know, on my answer key, I put these in a different order, so therefore this would be my y1, this would be my y2, which would mean my Wronskian would be negative e to the 2x, but, you know, everything comes out in the wash. It doesn't matter which one you call y1, y2. What are you guys getting for U1 prime? What happens to the e's?
Cancel.
Oh, cancel. Da. And then I get negative 1/3, what's sine times secant? Now it's all about, do you remember the integral of tangent?
Natural log secant.
And if you don't, you would write it sine x over cosine x, you do a u sub, you'll get there eventually. Right?
Yeah.
You guys with me? Yeah. So there's U1. So what's U2 prime? Now, real quick, I could write this as 1/3 ln cosine. Does everybody see how that magic happens? I could bring the negative up, which flips this. I think that's what I did on the answer key. U2 prime, what is it in general? Y1. F of x over W. The way I remember this, I'm sure you guys understand the 1, 2, 2, 1. But then this guy gets to go first, so he has to have the negative. That's the trick. So I don't know how you guys have to remember this. Alright, keep going. While you're doing that, I'm going to give out the answer key. This is going to take me a minute because there's 2 pages to it.
Thank you.
I could have fit it all on a note card. Oh, my writing is bad enough already. Oh. And make corrections. I'm a little concerned, like, where some things came out of nowhere, but yeah, make corrections for sure. And just in general, show all your work. Like, for example, this, I can't remember, I don't think they just gave you this. You're gonna have to show me what. Oh no, this is the one you have to work backwards.
Oh yeah, because you wouldn't have a particular solution, right? This whole thing, he just expanded it to x, and this one is supposed to be x, c2 sin x, and y1, y2.
Alright, let me see. So y1 for this time is cosine times 1/3 e to the x secant, so something really nice happens there. E's, oops, I left off my e. Yeah, e to the x cosine. So those die. Of course, cosine times secant is
1.
frickin' 1. So then what's u2? Huh?
1/3 x.
1/3 x. So then, my yp is going to be u1 times e to the x cosine x plus u2 e to the x sine x. So then my yc, I'm sorry, my y will be my yc plus my yp. Alright. Is that what I got on the answer key? I'm worried about past Jeff. Which one was this? That looks right. Yeah? Yeah. Okay. Yay! Or at least it's the same thing I got this time, so I never know. Okay.
Yes. I know that I remember the thing for the variation parameters, but how do we set up like the W1 over W part? Like I don't understand to set up the Wronskian, I guess.
So,
If I wanted to do the
is your question, alright, let me make sure. Is your question about how to set this up, or is your question about where this comes from?
pretty much, yeah, where that one comes from.
Where that comes from?
Yeah.
Okay, so real quick.
I know it comes from the Wronskian.
Oh, scheisse. Oh. So the Wronskian, so if I'm given, blah, 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 y1, y2, and I know my f of x, and blah, 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 so the, the system of equations we set up when we got to the end of plugging stuff in, when we did it the long ass way, right? And I don't have my notes from that just to show you. The if you set up the Wronskian, the determinant, just the you can do it, Jeff. You can do it, Jeff. From the system of equations, if you set up the matrix to solve that system of equations, this would be it. Then we use this very weird, obscure method called Cramer's rule, where we said to solve for one unknown, we would take this and overlay the first column with the answers from the system of equations. Yes? I don't know if you guys remember this. Cramer's rule, not used very often. If you feel like you've never heard of it, that's probably because you haven't. But it is kind of, so we did one concrete example where I showed you it actually works. I didn't prove it to you because I didn't want to now. So if you do this determinant, what do you get? 0 minus, this isn't you, sorry, this should be over, not this, anyway. So this will be 0 minus, this will be negative y2 f of x. And then if I divide by the Wronskian, then I get u1 prime. So that gives you this. And then part of Kramer's rule is if you divide by the determinant of the coefficients of the problem, it'll actually give you the answer for that one. So you too, I would do all the same thing except I would overlay this column with 0 f of x. So we did one concrete example of like a problem from algebra. Just a little 3x plus 5y equals 7 or whatever the hell it was. And then I showed you that it comes out to the same answer as if you just do it the regular old way. So Kramer's rule is really not used very often, but the few times we use it, it's stupid awesome. So this one we just get to the answer, bam, right? Okay, maybe. So if your trouble is, why does that work? I'll go look that shit up. So that's where it came from. Yeah.
Thank you.
You're welcome.
Could you explain what alpha and beta again are for like
Oh, alpha and beta?
when you get like an plus or minus?
Yeah. So if I solve an auxiliary equation and I end up with alpha plus or minus I beta, that's all they are. They're just the numbers that are there. So if I get m equals 4 plus or minus I rad 3, then alpha's 4 and beta's rad 3.
Okay, and
Yep.
then how do you go from that to the cosine sign?
Oh, so if it's a constant coefficients, then that's going to be your e to the alpha x cosine beta x plus sine beta x. Right, and it should be C1, C2. And again, shoot. Well, you wouldn't have been able to fit it in anyway, Jeff. There's a really cool connection. What is it if it's Cauchy-Euler?
It's the natural logs inside instead.
Yeah, it's going to be on the outside. It's going to be, and it kind of makes sense. Cauchy-Euler is all about x to the power, so this would be x to the alpha. C1 cosine beta ln x plus C2 sine beta ln x. Do you see how if I let x equals e to the t, these kind of become related? What's the natural log of e to the t? T. So if I let x equal e to the t, doesn't the form of this become this?
Oh shit, yeah.
Do you guys see that? So that's actually, from the beginning, if I'm given a Cauchy-Euler, I can let x equal e to the t. That transforms it into a constant coefficients. And then you get the answer. That's why they have such similarities between the two, because they're one substitution away from being each other. That's kind of nifty. Yes.
That could be an extra credit question.
Could be.
Yeah.
I don't think you would give us imaginary numbers on the.
Oh no, I said that earlier. I will. You can bet all the money you got on. You're going to get at least one problem that's got an imaginary solution. Just to let you know. Otherwise, what's the point? You got to remember how to do that. And it's kind of nice. You can see similarities between the two of those, which I always hope helps you remember. The book does, just to let you know, the book at the end of that section, the Cauchy-Euler section, it does talk very quickly about that substitution I was talking about. So if you're curious about it, you can look at that to kind of show you how that would look. Yeah.
Oh, I'm good.
All right. Anything else, guys?
So which section specifically will we be
Oh,
covering?
so I made 4.8 officially extra credit. We will do 4.9 after the next Thursday, right? Or next, yeah. So that'll be on the next test. So this test up through 4.7. Remember, 4.5 is also extra That's the annihilator approach. That's the big ass D. Instead of y double prime, you can have d squared to mean take a derivative twice. It's kind of nifty, but it's not used as much. So
Was 4.4 also extra credit?
No.
Or is that-
4-5. Yeah.
So
They'll be two.
doing-
All right, guys. See you guys next week. Where that?
Everything through 4.7.
Starting at 4.1.
Yeah.
4.1,
So you-
4.2,
Oh, you
4.3,
also. There's somebody else.
4, 4.5.
So both of you guys I asked,
6 and 7.
you can email me. I just have to remember to look. I think, so you missed the day that I gave them back, obviously, right? So I think I gathered everything up and it got put into a pile. I just gotta look for it. So it's my fault. If you think about it, email me and say, hey, can you look for that again? You know, just remind me.
4.6 and 4.7.
Oh, yeah. Oh, okay. So I've got you, let me see, make sure I got everything up to date. Yes, cool. So I've got you sitting right here. Oh, that's right. Okay. You already made corrections. It doesn't, that explains why that was lower, okay. Sorry, that's just me doing weird things. You're fine. Everything is right, everything's right.
Crazy, I don't know.
So you're currently
I
at
remember projection.
an 89.
And then it's, I don't know, dude. I feel like I was taking honors linear algebra course the entire time, bro. I had to memorize everything.
It's so weird. It's like I'm memorizing everything and I just forget it right after.
Yeah, it's
Bro.
so stupid.
Oh, let's see.
Yes, man. But that's
I
alright.
think there are several people
Yeah.
that also didn't get the quiz, but I think,
Bro, he's stupid nice, but I should not have gotten
so what I did was try probably the day that I gave it back. I collected it all, put it into the wrong pile. So I'm just telling people, can you send me an email, remind me to look for it?
Yeah.
So like, I'm pretty sure it's just in a stack of like homework or something else. Yeah. Okay. I just keep forgetting to look for it.
I couldn't stay last autism for the worksheets that you.
Worksheets? Which, sorry? Oh, you mean, oh, you wanna go up
Yeah.
and then okay, yeah, sure. Okay. You can head up there, I'll catch up to you if you want to, yeah.
Before you put in the worksheet, so like, can the answer key or whatever.
Yeah.
I need another one. Sorry,
What do you need?
the answer keys.
Oh.
That was a fun class.
Thank you, sir.
Sure.
Sorry.
I just had two quick things to say. First,